So in this video, I would like to demonstrate or show you some non-octet example. Non-octet simply means that the compounds, the atoms in the compounds does not obtain an octet structure. Say for example, one typical one is BF3. Boron, it has 3 electrons on its outermost shell, but fluorine, it has 7. For fluorine, it has 7 electrons. That means it would like to obtain 1 more electron so that they can obtain a noble gas configuration. So 1 electron is needed. Say, let's look at boron. Boron, it has 3 electrons on its outermost shell, 1, 2, and 3. Okay, and then we have 3 fluorine surrounding it. Would like to obtain a noble gas configuration. So fluorine, we share 1 electrons. 1, 2, 3, 4, 5, 6, 7. So each fluorine will share 1 electron from boron. So you notice when we count the number of electrons in boron, there will be only 1, 2, 3, 4, 5, 6 electrons. So in this case, it does not reach the octet structure, but still this BF3 compound is relatively stable. So this one is an interesting example. And another typical example, and actually it's a funny example, is nitrogen dioxide. Okay, nitrogen, we've got 5 electrons on this outermost shell, and oxygen, we've got 6. So nitrogen actually would like to, oxygen here would like to share 2 electrons from others, and nitrogen can actually share totally 5. So what nitrogen is actually doing here is sharing 2 electrons with the oxygen nearby. So oxygen, we share 1, 2, 3, 4, 5, 6. So this oxygen is now octet. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, so it's octet. And another 3 electrons from nitrogen will be rather interesting. 1, 2. These 2 electrons will donate a pair of electrons to another oxygen atom. So for this donation is it's actually I should say, this nitrogen would like to share these electrons completely with this oxygen without any return. So you notice for this oxygen 1, 2, 3, 4, 5, 6, 7, 8 electrons is already in octet. But this nitrogen has 1 more electron left. So when you count the total number of electrons, this nitrogen NO2 compound, it has totally 7 electrons. So it's not an octet as well. Okay, so if we join this, the structure of this nitrogen dioxide molecule, okay, we will have a diagram like this. Okay, it gives a dative covalent bond to the oxygen nearby. So after talking about the non-octet structure of the, it's actually less than octet. Okay, because this one has only 6 electrons and this one has 7 electrons in the central atom. And for other cases of non-octet, we would like to share one example called SO2. So sulfur, it has 6 electrons on its outermost shell, and oxygen has 6 as well. And this sulfur, it belongs to period 3. Period 3, normally it can contain 18 electrons, the maximum number of electrons on the 3rd electron shell. So it can expand this octet. We call it expand octet. Expand this octet, okay, so that it can contain more electrons. So it can share 1, 2, 3, 4. Okay, 4 electrons with a nearby oxygen atom. So oxygen can share 2 electrons with the sulfur as well. Another oxygen can share another 2. So when you calculate the number of atoms in this sulfur, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally 10 electrons is in the central atom. Okay, so quite different from what we talk about in the octet structure. Another typical example would be PCl5. Phosphorus has 5 electrons on this outermost shell, okay, whereas chlorine has 7. So phosphorus, again, it will expand its octet. So 5 electrons, so sharing 5 electrons with the nearby 5 chlorine atom. And the chlorine atom would like to share 1 electrons with phosphorus as well. So at the end, we can obtain a structure like this. And this one is the last one. So you notice, actually this PCl5 again does not follow the octet rule. When we cover all the chlorine, we count the number of electrons here. This phosphorus containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons as well. So by this video, you'll notice actually some of the atoms in a compound, they will follow octet rule. Mainly, they will try their very best to follow octet rule, but some of them are not. Say for example, if we're talking about less than octet, then most probably they will belong to period 2. Period 2, and actually only 2 atoms, they will try to follow the non-octet example. But for period 3 or above, actually they can start to expand their octet to share more electrons with others or accept more electrons from others. So by taking these few examples, hope that you understand the theory or some phenomena that we can't explain before, and try to finish the worksheet so that you can understand more about octet and non-octet structure.